Hey class, Mr. Husted here, back for Chapter 6, Lesson 4, if you remember back. And if you can hear it, that's Mr. Brooks in the background. Coming to you live here from room 111. We are talking about proving similar triangles. If you remember back to Chapter 4, we were trying to prove triangles were congruent in all the different theorems we had there. This chapter, we're trying to prove that triangles are similar. Last lesson, you learned about the theorem angle-angle. If we have two congruent angles with two triangles, we know that they are similar. Today we're going to be doing side-side-side and side-angle-side. Okay? Side-side-side for similarity is just a little different. Before, if the three sides were all congruent, then the triangles were congruent. This time, if they are proportional, then they are similar. So basically, what we've been doing so far is that as long as the sides are proportional, then the angles will also be congruent. So let's take a look at example number 1. We want to use the SSS similarity theorem and determine which two triangles are similar. Now, some of you may ask, how are we going to figure out which sides go with which? We can look, first of all, they are color coordinated, which I think is great. But also, if yours is in black and white, yours isn't going to be color coordinated. With a triangle, you're going to have the longest side, you're going to have the shortest side, and then you're going to have the side in the middle. So when we go to compare these triangles, we're going to compare the two longest sides, the two shortest sides, and then the two sides that we haven't even talked about yet. Okay, so I'm just going to label these 1, 2, and 3. We're going to compare 1 to 2 right now. Okay, so we are going to do 16, the longest side from 1, over 12, the longest side from 2. 4 goes into both of those, giving me 4 over 3. Okay, let's go with the shortest side then. We have 8 and we have 6. That will simplify down to 4 over 3. And then the two sides that we haven't used yet, so we used 8, we used 16, we used 6, and we used 12, would be 12 over 9. 3 goes into both of them, so we'd have 4 over 3. So with these all being the same, we could state that triangle ABC is similar to, now we have to be careful again because I went from A to B, so that means I would have to go from D to E, would be congruent to triangle DEF. Okay, so now that we have compared ABC to DEF, we want to also compare ABC to GHJ. So again, we're going to take the two longest sides, the two shortest sides, compare them, and then determine it from there. So the longest side, again, was 16. 16 over 16. That's going to give me 1 over 1. And then we're going to take the shortest sides, which would be 8 over 8, which would also simplify to 1 over 1. And then the sides we haven't messed with yet, which would be 12 over 10. And that's going to simplify down to 6 over 5, which does not match the other two. So 1 is not congruent to 3. Okay, so that's how you can kind of use the SSS theorem to prove similarity. You just compare all of the sides. Okay, now we're going to use the SSS similarity theorem to find the value of x. Okay, if you notice down here, we have two sets of x's. Whoops, I didn't want to cross it off. Kind of wanted to highlight. We have an x here and we have an x here. You can solve for one of them. I can tell you that it's going to be easier to solve for this one first than it is to be for this one. Okay? All right, but what we're going to do is we're going to set up a proportion, just like we did before. All right, so again, you can use the picture, you can use the statement. I know that x minus 1 is on BC, so I'm going to write x minus 1 on top. BC corresponds to, if I look up here, it's the last two letters, so it's going to be the last two letters over here. So EF is going to be 18. Now I want to use the sides that does not contain 3x, or 3 times the quantity x plus 1. So I don't want to do DF, I'm going to do DE. So on the bottom will be 12, and that corresponding would be the number 4, okay? Because DE would correspond to AB, and that's 4. Same thing we've been doing. We're going to cross multiply. The key here is making sure that we take 12 times x and 12 times 1. Okay, and that's going to be equal to 4 times 18, which is 62. Nope, just kidding. 72. Okay. We will add 12 to both sides. We'll get 12x equal to 84. Divide by 12, divide by 12. X equals 7. Okay. Now, had you have chosen to use this one, you would still find that x equals 7. It's just a little more math involved in order to determine that. Okay? All right. So, let's flip over to the other side. We've talked a little bit about sides. Talk a little bit about side angle side. Remember, the key with side angle side is that the angle must be in between the two sides. Okay, so again, the two sides are proportional and the angle included is equal. So if we're looking at it over here, this side must be with this side, and this side must be proportional to that side, and the angle included in between them. So the angle here is what must be there. Okay, if that takes place, then those two triangles are similar. You don't need to know any other information. All right, so we are building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so it is similar to the left using the angle measure and lengths shown? Okay, so what we have to do in order to prove the SAS similarity theorem is, first off, we have to prove that the angles are the same. And if we look, 53 degrees is 53 degrees. That's good. So let's just do this. So we have side, angle, side. We have done the angle part. The angle part checks out. Now we have to take a look at corresponding sides and make sure that they are proportional. So doesn't matter how you want to set it up, if you want to go from the left to the right, if you want to go big to small. I'm just going to go with, saying that this is our new image, this is our old image. So I'm going to do 9 over 6, which simplifies down by 3 to 3 over 2, and then 15 over 10, which they're both divisible by 5, which would give me 3 over 2. So both sides check out. So you would simply say that the answer to this is yes. You could use side angle side to prove that the right side is similar to the left side. Okay? Now, lastly, you have 3 options. You have angle, angle, you have side, 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 and you have side, angle, side. Choose any method you want to show that these two triangles are similar. Okay? Right now, you should hopefully see that you have a side and a side. I personally would say that that rules out angle, angle, because we have 2 sides here and we have 2 sides here. So first off, let's see if they are even in proportion. Okay? Again, we are going to take the sides that are, we're going to take the shortest sides and the longest sides and compare them. Either way you want to. I know 9 is the shortest side. I know 15 is the other shortest side. Simplify that by 3. You get 3/5. I know 18 is the longest side on that one. I know 30 is the longest side on that one. That will also simplify down by 6 to be 3/5. So right now, we're good. The 2 sides that we needed, they check out. The question is, can I prove anything else on here? Can I prove that these side lengths, because I need this third side length for side, 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 can I prove that those two are in proportion with the other two? I don't have any measurements there, so there's not much I can do. It's not a right triangle. Can't use Pythagorean theorem. The only thing I can do is hope that you remember that when 2 lines intersect, they create vertical angles. So I could simply say that angle ACB is congruent to angle, and I got to make sure I do the same way, so it would be DCE, angle DCE, and they are congruent by the vertical angles theorem. Okay, two lines intersect, create two sets of vertical angles. Because of that, I now know that I can solve this for side, angle, side, because I have my side here, and the angle in between. Side, side, and the angle in between. So I could say triangle A, B, C is similar to triangle, and we got to make sure we say it in the right way. So DEC. Okay, by side, angle, side. Okay, so again, we're kind of going back to chapter 4. We were trying to figure out how triangles were congruent with a minimal amount of information. Only this time we're trying to figure out if they are similar. Okay, so that's all we have for you today. If you have any questions, bring them with you to class, and we'll see you then.